Hello friends, in my last video I explained you overlapping of the orbitals. That is, overlapping means when the two orbitals overlap head to tail, that is head to head, that forms the sigma bond, and when orbitals overlap laterally, they form the pi bonds. Now today I will explain you hybridization. Hybridization means mixing or fusing of the two orbitals, simple way. But what are the conditions how the hybridization takes place? And because it is very important that hybridized orbitals they take part in the bond formation. When two different orbitals of the same somewhat different energy, they fuse or combine to each other to form the same number of the orbitals of the same energy. Listen, when the two orbitals, suppose S and P orbitals is of different energy, they combine together or fuse together, form the same number of the orbitals of the same energy, that is equivalent energy. That is very much important. So for the characteristic geometrical shape of the molecule, Paul was the man who gave a concept of the hybridization of the atomic orbitals. Very simple example, if you take two balls, one is bigger, other is small, and the energy is different. When both they fuse together to form the two balls of the same size of the same energy, it is clear. See, the point is that two different orbitals, suppose S and P, their energy level is different. When they fuse together, again form the same number of the orbitals, but of the same energy. This was the concept, that is calling new concept of the hybridization of the atomic orbitals. Atomic orbitals of the different energy combines to form new set of the equivalent orbitals are called the hybrid orbitals. So hybridization is a process. Intermixing the orbitals of the different energy. Listen, hybridization is a process intermixing of the orbitals of the different energy, redistribute their energy, forming the new set of the equivalent energy orbitals. Equivalent energy orbitals, and it is very important thing because it is used in the forms of the bond. So, hybridization is a process intermixing the orbitals of the different energy, suppose S and P orbitals, then they redistribute their energy, forming a new set of equivalent energy orbitals. That is known as the hybridization. Now there are different type of the sp hybridizations. That is sp hybridization, sp2 hybridization, sp3 hybridization, spd hybridization. So today I will take one by one with examples. First is sp hybridization. Now sp, it means one s and one p orbital. What is sp hybridization? It means one s and one p orbital mixed together to form the two equivalent hybrids orbitals. Now here 1 and 1. So character will be the 50-50, that is 50% character of the s bond, s orbital, and the 50% character of the p orbital, and they will be in opposite direction, and it will form a linear arrangement. If we take an example of beryllium chloride, beryllium configuration is 1s 2s2, Now the 2s2 and the p orbitals are vacant. Now in excited state, one of the electron of the 2s promoted to the p orbitals. That is two unpaired electrons. They hybridized to form the two sp orbitals of the same energy. Now these two orbitals of the same energy, that is beryllium, they overlap with the p orbital of the chlorine. So we say that the shape is given, that is a linear hybridization, that is beryllium 1s1 2s2 when excited, one electron of the 2s promoted to the p orbital and then sp hybridization takes place and this beryllium overlap with the p orbital of the chlorine and the chlorine. So it forms a linear hybridization. Angle is 180 between the chlorine and the chlorine. So this is the sp hybridization. Now second is sp2 hybridization. As s and p2, it means one s orbital and the two p orbitals. One s and the two orbitals, they form the three equivalent orbitals, that is sp2. Now here, as 1s and the 2p, then the character will be s is 33.3% and the p character will be 66.7%. Now for example, we take boron chloride, that is BCl3, and if we see the electronic configuration of the boron, that is 1s1, 2s2 and the 2p1. Now here, in excited state, one of the electron is promoted to the 2p, that is 3 electrons unpaired. Now these three, they will hybridize to form the 3 equivalent hybridized orbitals, that is sp2 hybridization takes place. Now if you see the structure in boron, 3 sp hybridized orbitals, they overlap the p orbital of the chlorine, p orbital of the chlorine and the p orbital of the chlorine, and it forms a trigonal planar shape. It is trigonal planar geometry or the shape. Here we see the angle between the two chlorides 120 degrees centigrade. So angle between the chlorofluorides 120 degree, it is a trigonal planar geometry. So this is sp hybridization where character is 50-50 and it is sp2, that is 1s p2, here character is 33.3s and 66.7, that is p. So in the case of the boron chloride, if you see the electronic configuration of the boron 1s, 2s, 2p, here in excited state, one of the electron of the 2s promoted to the p, and these 3 unpaired electrons, they hybridize to form the sp2 hybridization, and these 3 hybridized orbit, they overlap with the p orbitals of the chlorine, chlorine and chlorine, and it forms a trigonal planar geometry. Okay, now in my next video I will explain the sp3 hybridization and the spd hybridization. Please go through my all the videos regarding atomic structure and the other properties of the atoms. If you like my videos, please share and subscribe. Thanks very much.